If you are familiar with parallelism, especially in C#, that is the topic of this video, you might think that, or maybe your friend, your colleagues might think that parallelism is the answer of everything. You can solve all the performance problems, all the things that are related to the speed or execution time can be solved by parallelism. No, it's not like that. Today, I'm going to talk about parallelism antipatterns. What does this mean? Let's see. If you abuse these things, the cost of such development or choice would be a lot. It makes things worse. Really? Yes, I will show you. So, there is some places that we should not use parallelism, or we should use them in a managed way. So by asking a simple question, we will jump to Visual Studio and see what is going to happen. Do you think parallelism can always decrease the execution time? You might say yes, but I will show you it's not like that. Not always. So we do not wait. We go to Visual Studio and see some things in action. Let's have a look. The first one. Let me... Okay. Let me explain. A stopwatch is a stopwatch. You are familiar with. This is a simple integer value, like this. Another one, sum. A stopwatch would be started, and then a simple task.run with a for loop. I need the sum of the I value. That's all. Very simple. And then you will see the result without parallelism. I mean the time that a stopwatch would take for us. Okay. Or would measure for us. Okay. And then I will restart the stopwatch and use parallel for like this. And again, we will check the time. You want to see the result? Okay. I will show you. Okay. This is the result. Time without parallelism. Time with parallelism. What happened? We thought that using parallelism would decrease the execution time. No, not always. See, here, a simple for loop is faster than getting so many CPU cores and do things in parallel. So, be careful. So, it was the first example. This means using unnecessary parallelism. Okay? Okay. First flaw, unnecessary parallelism. What is the next one? Before going to the next one, I should comment all of these things out to make things easier. Okay. The second one. Race condition. What is race condition? Let me show you. If I run this code, I am expecting to always see this number. Okay? But since I am using parallel for, it won't be like that. It allocates the place that this item, this variable, would be stored to one of the tasks, one of the things that is going to happen. So if I run one time, you will see this number. Another time, you will see something different. See? This means race condition. If I want to talk about race condition in details, it would be a long story. But at least you could see what is going to happen. What is the solution? Very easy. See? Using lock. Like this. I am getting an object and then lock it like this. This means I will wrap my big sum into a lock like this. Then if I run, see, I will get the expected result. It wasn't the only solution. There is another solution also. See, forget this. Use interlocked increment. By this also, the problem can be solved. See? So, what is the solution? Using lock or using interlock, like this. So, you can solve the race condition problem by one of these two. And now, you know about race condition. Let's jump to the next one. This one is obvious. See? Nested parallel. I mean using a parallel 4 inside another one. It's too bad. It can make a very big mess for you. Never do that. So this is one of the things that you should be sensitive about, that using too much parallel type of things inside each other, especially these things can make your code a little bit unpredictable. You don't predict what is going to happen. So this is another problem that can make some issues if you won't be careful. This one, no need to fire and run anything. Oh, this one is again so important. See, some objects in C# are not thread safe, like random, for example. So, when I do this, sometimes even in this loop, I get same results. Random values are supposed to be different. But in this simple loop, sometimes I get same results. So for example, here, I'm trying to store the values into this list, and then we'll check if they are the same and it can be found inside the list. I will print them out. Okay? If I run, I already did. Sometimes I get nothing. It works fine. Sometimes 1 value, sometimes 6 value. So this means non-thread safe objects are a little bit troublesome when we gonna use parallel 4. Let's see. Wow, see? If we were doing something critical and things should have been 1,000,000% random and unique, then see, I have some exceptions. They are not unique. Even in a simple loop like this, I'm supposed to repeat it just 1,000,000 times. See? I have repeated values, duplicated values, which is bad. So be careful about these things. Also, you can solve this problem by lock again, but I won't do that. You do it yourself and comment it under the clip. Then I will see and have a look. Thank you so much. Continue coding.